Okay, so we are in Statistical Rethinking, second edition, and we're just beginning chapter 11 here. And so we'll go through questions 11 through the easy ones, through E1, E2, and E3. Okay, so first question here is, if an event has a probability of 0.35, what are the log odds of the event? Right? And just for a little bit of context with the book, hopefully again you're reading along, but the log odds are what is used in logistic regression, which is a major type of regression for binomial events, such as the globe tossing example that has been used throughout the book. So to get the definition, or to get the log odds of an event with probability 0.35, let's just start with the definition of the odds, which is just p over 1 minus p, so the probability of the event occurring divided by the probability of the event not occurring. And then we just take the log of that, and it's important that we're it's important that we are using the same base of our log all the time, and so I will just always be using the natural log. So I'll denote that with ln. But anyway, so the log odds obviously is just the log of the odds here. Okay, and so if we go through and if we do all of that, we get the log of 0.35 over 1 minus 3.5, which is this, and we get this is our log odds, rounded to just 2 decimal places. Okay, we can also do that in R pretty easily. Okay, but that bit of code here, and you see this is the answer we get. Okay. For 11E2, so now we're going the other way. So now we have log odds of 3.2, right? So we have basically what would be this value here, okay? And we're going back up the chain to find P, okay? So we're given the log odds, and now we're looking for the probability of the event. All right. So in R, this is really easy, right? It's just this line of code here. But I think it's good to know how to calculate this by hand, just because it's very easy to accidentally use the wrong bit of code, and you want to be able to verify it in simple cases and so on. So so to do this by hand, you can go through this calculation here, but it kind of goes like this. So we have our log odds, which is 3.2, and we know that that has to equal the expression for log odds, right? So this is our expression, and we're going to look for P, okay? So as I start to try to solve this, the first thing I'll do is just exponentiate both sides. So now I have e to the 3.2, and by taking the exponent of, or the exponentiation of the natural log, right? Well, then I get just the odds. So now I have this expression. So now I'm going to try to get p by itself, so I'm going to multiply 1 minus p over to the other side. Okay, and so if I just distribute the e to the 3.2, I get e to the 3.2 minus p e to the 3.2, and that equals p. Okay, well, I still want to get p all by itself, so I'm going to add the p e to the 3.2 over. Okay, so now I have the e to the 3.2, right, because I've added it from this side, equals p to the p plus e 3.2, okay, and so now I'm just going to take out the common factor there, which is p. So now I have p times 1 plus e to the 3.2, okay, and now I have that p. I wish it didn't break right there, but p equals e to the 3.2 divided by 1 to the e to the 3.2, and we get this value right here, right, which agrees with our R calculation. Great. Okay, so now finally, 11E3. So suppose that we've done logistic regression, and we have our beta coefficient equaling 1.7. What does this imply about the change in odds of the outcome? Okay. Well, so I think that this is asking about odds. Okay, so we'll get there, but let's just first break it down into the log odds. So on the log odds scale, a coefficient of 1.7 means that the log odds increase, importantly, additively, I'm not really sure if that's a word, but we'll go with it, by 1.7 units for every one increase in the corresponding predictor variable, right? So, in other words, our log odds would equal our linear predictor, and part of that linear predictor would be 1.7 times x. So in other words, our log odds would increase by 1.7x. Okay. But I think we're being asked about the odds scale, not the log odds scale. So in order to figure that out, all that we need to do is to exponentiate both sides of this kind of little mock equation here. Okay? And so when we do that, the log odds just becomes the odds. Okay? And then if we exponentiate this whole linear equation over here, what we then get is every beta coefficient times its predictor variable, instead of being added, now become multiplied, right? So we exponentiate all that, and then it becomes this multiplication type thing, okay? And so now the odds are increasing multiplicatively by e to the 1.7 for every 1 unit increase in x. Okay, so that's how the odds are changing. Okay, so I hope that makes sense, and we'll call that good.